Hi, I'm EarthPressure, course instructor for Geotechnical Engineering 1. In this presentation, we will learn about lateral pressure. Lateral pressure is the pressure that soil exerts in the horizontal direction. Lateral pressure has to be calculated to design structures like retaining walls, bridge abutments and basement wall, etc. Now we will find out what do we mean by surcharge. So here we can see a retaining wall of height h and there is a surcharge which is shown here with the help of arrows. The surcharge loads acting on retaining wall are the additional vertical loads that are used to the backfill soil above the top of the wall. Here the dotted portion represents the backfill soil and on top there is a surcharge. And this surcharge can be either dead load, for example, it can be horizontal or a sloping backfill above the wall height h, or even it can be live load which could result from highway or parking lot, paving or adjacent footing. There are three types of wall movements. First one is the wall moves away from the soil. Here we can see the original position of the retaining wall, and when soil pushes the wall moves away from the soil with which it was in contact, and this condition is referred to as active case. And here we can see that there is no movement of the retaining wall and even there is no movement of the soil. So this is referred to as at rest case. And in the third one, we can see that the retaining wall is pushing the soil. That means the wall is moving into the soil, and this type of condition is referred to as passive case. There are three states of lateral earth pressure. First one is K0, which is at rest condition. Next is Ka, active earth pressure, and Kp, passive earth pressure. Here in this figure, we can see the conditions in case of active earth pressure. H is the height of the retaining wall, and this retaining wall is supporting the soil. When the soil moves towards left hand side, there will be shearing resistance offered by the soil, and the line represents the surface of sliding or rupture, and here we can see the wedge which is known as sliding wedge. This shearing resistance acts opposite to the direction of the movement, and this type of condition is known to be active earth pressure. And in the second condition, we can see that the wall tries to push the soil and there will be resistance offered by the soil in the opposite direction, and this inclined line represents the surface of sliding or rupture, and the wedge is called as sliding wedge. First one is at rest condition. Here in this case, soil in nature have an in situ state of stress. This in situ state of stress is referred to as at rest condition. If a natural surface is level and all stratigraphy is also level, then the at rest state of stress can be described by two main stresses. Here we have considered a soil element in a soil mass. Sigma V represent the vertical stress which is shown in downward direction and also in upward direction on the other side. Similarly, horizontal stress is represented by sigma H, one on the left hand side and the other on the right hand side. Next is active earth pressure coefficient K. It is ratio of horizontal and vertical principal effective stresses when a retaining wall moves away by small amount from the retained soil, whereas Passive earth pressure coefficient Kp is the ratio of horizontal and vertical principal effective stresses when a retaining wall is forced against a soil mass. Third one, coefficient of earth pressure at rest K0 is the ratio of horizontal and vertical principal effective stresses when a retaining wall does not move at all, that is, it is at rest. K0 is equal to sigma h divided by sigma v. All effective horizontal stresses are sigma h will be equal to K0 into sigma v. So, for at rest condition, coefficient of lateral pressure is K0 equal to 1 minus sin phi for normally consolidated soil. A stiff gravity wall fully on bedrock will feel the full at rest driving soil pressures. The Rankine active and passive earth pressure coefficient for the specific condition of a horizontal backfill surface is calculated as follows. First one, for active case, Ka equal to 1 minus sin phi divided by 1 plus sin phi, which is equal to tan square of 45 degree minus phi by 2. Similarly, for passive case, Kp is equal to 1 plus sin phi divided by 1 minus sin phi, which is equal to tan square of 45 degree plus phi by 2. Thank you.